have an ice cube tray. And the ice cube tray is 12 by 12. Okay? Has 12 hemispheres inside the shown below. The depth of each hemisphere is 1 centimeter. Give all answers in terms of pi. If all the hemispheres were filled with water, calculate the total volume of the ice cube tray could hold. How many hemispheres do you see? How many? I see 12 hemispheres, okay? Next thing. 12 hemispheres is how many spheres? Is everybody happy with 6 spheres? Because 12 hemis is 6 spheres. So what's 6 times the volume of 1 sphere? So 6 times 4/3 pi r cubed. So 6 times, what is it then? 4/3 pi, what's radius? Cubed?
1.
Plus 1 cubed. Do I have to use a certain pi value? No, it says give all answers in terms of pi. So somebody throw that into the calculator for me and give me the answer really quick. Pretty sure it's 8 pi.
Yeah.
8 pi centimeters cubed. Is that okay? Move on to part 2. Calculate the total surface area of one of the ice cubes, of one ice cube from the tray. What shape are the ice cubes in again? Huh? And what did we agree is the formula for a hemisphere? We did it earlier. The area of a sphere is this much, so what do we do? Sorry, the curved surface area of a sphere is this much, so what do we do for this part here? Q pi r squared, and what about the extra circle? Add them together. Yep. 3 times pi, what's the radius again? I think Dylan told me a second ago. 1. 3 pi times 1, anybody? 3 pi centimeters cubed. Calculate the total surface area on top of the ice cube tray, excluding the sections covered by water. Only on the top part. That's interesting. Let's go back. Take an eagle eye view of this. What do you think it is? It's actually a square. Take away how many circles? No, not six circles, I'm afraid. I think it's going to be. Sorry, this is not drawn to scale, but you get the gist, don't you? It's going to be a square. Take away 12 circles when you're looking at the area only. Do you get what I'm saying? So what's the area of one of these circles? Pi r squared. What's pi r squared? Pi times 1 squared. How many of them is there? 12. So I'd say 12 pi for all the circles. Does that make sense? Because the area of one circle is 1 pi. What's the area of the tray itself? 12 times 12? So 144, take away the area of the square, take away the area of the 4 circles, is going to be 144 take away. What do we get? In terms of pi, you just have to leave it like that. Because it says all answers in terms of pi. You won't give the decimals in this case. You all good? Right. Question 4 done. Well, I'll do the lagging jacket one today. Alright, question 9. Any ideas how to do this one? What do you reckon? Find the curved surface area in terms of pi. Start the whole thing. Alright, good news. The inside of a sphere and the outside of the sphere are actually the same area. Do you get what I'm saying? So, the outside edge, which would be this part here, is actually the same as the inside. Do you get what I'm saying? So, it's actually the same amount of area. So, what we have to do is we have to find the volume of a hemisphere. So, for the red part, not the volume of a hemisphere, the curved surface area of a hemisphere. Do you get what I'm saying? Only one problem though. What's the problem? You don't count the top part, do we? The top part is empty. If you're struggling to visualize this, imagine I had a cylinder with a little ball shape on top. I could fit a ball directly on top of it, couldn't I? I could sit the ball directly into that item, couldn't I? What happens when I remove the ball? There's no circle on top, is there? So since there's no circle on top, what does that mean? What do you say? Yeah. So on the outside, see the green part? Actually, I'm going to rub out that red part there. Okay, just going to rub out part of the red part. See the green part, everybody? The green part is the entire cylinder. You get what I'm saying? The entire curved surface area of a cylinder. What's the curved surface area of a cylinder? 2 pi r h. What's on the inside then? Half the curved surface area of a sphere. What's half the curved surface area of a sphere? 2 pi r squared. Then what do we do then? 2 pi radius. Radius is 7, height 20. And you put all this into the calculator. What you get when you throw all that in really quickly? Come on. Anybody? Oh, sorry guys, I'm skipping the question, am I? Sorry lads. We're just asked for the cylinder at the start. My fault. So at the very beginning, we're just asked for the cylinder, and what's the cylinder? 280 pi. You close that door for a second, please. Thanks. Now the hemisphere is cut from it, and when the hemisphere is cut from it, you got to add on the hemisphere onto the answer. So what happens when you add on the hemisphere? 2 pi times 7 squared, and what you get? 300 and? Yeah, that's your two answers. Sorry guys, I know it's a bit rushed, okay? So I did 4 and, what did I do? 4 and 9, was it? Alright, I want you guys to do 18.6 as well. I want you to do question 1. I want you to do question 6. Just 1, 6 and 7 actually. 1, 6 and 7. Is that alright with you guys?